This is the way the podcast is made. A dude sitting in the corner with a laptop.
And you wonder why we don't do video.
Hello and welcome to the Hackaday podcast, special Los Angeles Airport edition. I'm Elliot Williams.
And I'm Al Williams, not an LAX.
And I'm Tom Nardi.
This is episode 243. We'll be talking Supercon, super printing, and super gyros. So I'm walking through LAX and I'm like, I need to find a place to podcast, and I have to go in this quiet corner, and there is a Supercon shirt, and I turn around and it is a bit loony. Hello. Unbelievable.
Oh man, and I was streaming. I was just trying to stream in a bad quality because I have a Wednesday streams, and here a special guest on my stream, Elliot Williams. That's so cool.
So I tap him on the shoulder and I'm like, excuse me, sir, nice shirt.
Crazy.
Yeah, totally.
Yeah.
Well, I'll let you get back to it, okay?
Thank you. Yeah.
Safe flight home.
The TSA is not going to know which of you to come for first, I think.
Well, he flies out a couple hours before I do, so they'll get him first, I think.
Well, how was your Supercon, Elliot?
Mine was fantastic. How was yours?
Absolutely great. It was just awesome to see everybody out. And, of course, you know me, I see mostly the soldering competition, but it was very lively as always.
There was a photo finish, right?
It was. It was like if we had scripted it. I mean, I'm surprised somebody didn't accuse us of scripting it, because it was just that last second dead heat. And so everybody was on the edge of their seat.
And I was watching all of the badge hacks. People were having a really good time with it, which was incredibly gratifying because I did some of the design work. Also, Voya Antonich from Supply Frame Design Lab did the visual design. The thing looked damn good. He did a really great job. And I know someone who did some operating system work on it.
I have no idea who that could have been.
So, good job, team effort. There's a possible chance that Tom Nardi is going to come by pretty soon. So if he does, we'll have to splice him in later, see what he thought about Supercon. But dead tired, but super fun time. Yeah, so how was your Supercon, dude?
It was phenomenal. I mean, I guess that's a given, right? Do we ever have a bad Supercon? I think, now that I've said it, right? But I've never had a bad one, and I would dare say they are only getting better with each one. It was awesome to see, what people came up with the badge. I admit I was mistaken for being concerned early on. I did have some concerns over the analog nature of the badge. Some people might not get it, but I was wrong to underestimate the Hackaday community, because they really did. I mean, I think we saw more badge hacks this year than last year, possibly.
Could be.
I mean, they really, and from all angles. I mean, there were a couple ones that did replace the firmware. We kind of anticipated that, but most of them, used the vector scope as Elliot intended, and it was really awesome to see. And it's such an awesome event. There's really nothing like it, and it is the highlight of my year. Like, now I'm in the low period between Supercons. I have to wait for the next one.
Winter starts today.
Yeah. It's true. I came back to the East Coast and it's cold and dark, and I was like, oh, this is the world without Supercon.
Yeah, no, it was really awesome to see people working on the vector scope side of things. And I knew that the Pico wasn't up to the task of doing crazy super graphics, because for those of you who don't have the badge, there was one side that had an ADC, and this drove basically a scope display in XY mode. And the other side was a DAC driven by the chip. And so can you make the voltages that make pretty pictures show up on the screen was the idea. And a number of people just totally sidestepped the Pico that was on there, brought in some beefier computing power. Either, their laptops, they just plugged the audio out of their laptop in, or Sprite and Mike Abbott. I can't believe Mike Abbott did asteroids. That was
awesome.
That was my stretch goal. Maybe in some universe where we have the most brilliant collector of hackers, somebody will be able to hook up asteroids on this thing in a weekend. And he did.
It was. I remember us talking about that you were like, yeah, it won't happen.
It won't happen.
If it does, that'd be amazing.
And Sprite, of course, then, does some maze crawler game and then ports a wireframe Doom to it. well, to the ESP32 that he's plugged into the ports, but it was rendering a wireframe Doom in analog voltages onto this like simulated oscilloscope screen.
Yeah, but I
Whoa.
liked his quote, Elliot, where he was showing the original one, and then he said, "Of course, only an idiot would try to port Doom in a weekend. So here's Doom."
Yeah, exactly. But it's really amazing what people did. And the Etch-a-Sketch crew, they didn't get enough applause. I really wish they demoed their thing more, because all that was two potentiometers. And they make a voltage divider, and that makes the point move around the screen. And they put it in infinite persistence by hacking the graphics palette, and boom, done. But then they wrapped it up in this really sweet 3D printed case. I mean, that by itself is just so clean, so smart, so awesome. But then with a sweet 3D printed wrapper over the top, kudos.
I was talking to those guys, and they said people kept on trying to like turn over the 3D printed frame and be like, "Oh, what microcontroller is in here?" And they're like, "No, this is the wonder of analog electronics. It's just two potentiometers and exactly what it's doing, exactly what you think it's doing. There's no analog to digital going on here. This is, and you could, it felt so. I don't know if you got a chance to go hands on with it. It felt so good, like just incredible responsiveness with those potentiometers they used. Yeah, I agree. That was an awesome one to see.
There were also a ton more that people didn't present, and like I got a chance to like look over people's shoulders while they were hacking on them, talk to them about it. I thought that was really neat too. I totally understand that like not everybody wants to stand up there in the limelight. It's
Right.
Yeah, it's stage lights are bright, man. But I have to say that what we ended up seeing is probably only half of the hacks people did. And it's really neat to see just people working on it, having fun. There were some cool synthesizer ones. There were a bunch more. And like none of the ones that showed up on stage were bad. They were all great. And that was just like, that's why we do this.
And I have been seeing some people putting their badge hacks up either on GitHub or IO or whatever. So I would definitely say, if you were one of the people who did something cool but didn't want to get up in front of hundreds of screaming nerds, at least put it online somewhere and share it. And we're probably gonna do some kind of a roundup. You can see these things up close, because it is amazing. The Al will get it. They all look like little Borg cubes to me, where there's all this weird hardware has been, picked up from the alleyway and attached to them.
Funny you mentioned the alley, right? Anyway, super, super fun time. I'm sad to be going back home, but, that means we get to go back home to the comfort of our real computers and write this stuff up. So our loss is your gain, right? Yeah, and thanks, Tom, for covering the Hackaday prize. This was the 10th and last Hackaday prize, and I think you opened that article up just right by mentioning how much it's done, and that we should be really stoked when we look back on how much was achieved with the Hackaday prize. And not,
Absolutely.
Not so much worrying about it not being around in the future. And part of the reason for that is that we're going to be doing similar but smaller scale, more focused contests in the future. And so now, where it's this like 9-month long event with 5 different subcategories and 50 winners, and it's just this crazy gigantic thing, we'll be focusing on much more tangible, much smaller goals in the future, and hopefully get just about the same amount of goodness out of it. So knock on wood, stay tuned to see what's coming out of Hackaday contests in 2024.
Yeah, I like that. With the smaller contests, we can be a lot more, reactive to things that are going on. You don't have this, year-long thing. And I know, several people had said to me, "Oh, it's a bummer that Hackaday prize is ending. Like, I was going to enter next year." And it was like, well, how many times have you said that, right? I think that sometimes, in some ways, like the scale of the Hackaday prize might have kept some people out of it. It was a big investment to put that kind of time in, and there's also some pretty serious teams and stuff in there. So there was, I think, maybe a little bit of, you feel like you got to be this high to ride for the Hackaday prize. So I think being able to do smaller ones, a shorter duration and more targeted, I think it's gonna be good. I think it's gonna get more people energized and it's natural to be a little bit bummed about the end of the prize, but it's certainly not going to be end of creative hacking. So that is alive and well for sure.
Oh my God! And a couple other people asked if this is the end of Supercon, and the answer to that is by no means, absolutely not. We have to think up something new to celebrate on Saturday night, but Supercon goes on, ladies and gentlemen. We're gonna have to have a different party, but same event, different party.
I imagine we could schedule some contest so it still ends on Supercon.
Halloween ends on Supercon every year, right?
Yeah, okay, there you go. We'll announce the Halloween contest winners or something.
This is a journey into sound.
What's that sound?
What's that sound?
Shall we head on off to What's That Sound?
I think we should, although I can hear plenty of sounds. I'm not sure I could guess any of them.
That sound is a flight to India boarding.
Yeah, screaming child and gate agent paging. Yes, that's my guess.
No, go listen to the What's That Sound from 2 weeks ago now. It was picked by Christina Panos, and it totally stumped me.
My guess is it's some sort of rubber stamp, one of those self-inking rubbers.
Man, you got that dead right.
Are you serious?
Yeah, she said it was a Trodat self-inking date stamp.
Score.
Damn.
I've heard a lot of those in my childhood, so that's really surprising.
I've been using this one since 19. It's a Trodat Printy-Dater 4820. It has beautiful typefaces on it, but they're all rubbed off now. It stamps just month and date and year, like a library stamper.
Exactly. Well, you're in good company because 110 people wrote in on this one, and of them, 46 got it right. The others were all saying it was a Dymo label maker, which isn't so bad. Oh, a stapler. Yeah, I hear that too.
Or a train ticket punch.
Right, exactly. Nope. It's pretty solid. Everybody else was sound of a self-inking rubber stamp. People sent me links to what rubber stamps looked like. I swear to God. The satisfying sound of a fresh company stamp applied to an invoice for a customer. I'll take that anyway. Self-inking stamper, possibly a date stamper, an automatic stamp used in offices way back when. Everybody had fond memories of the sound. It was ridiculous, but there were, like I said, 46 correct answers.
I got a random number from the web if you want it.
I'll take yours. What's yours?
28.
28, and that is congratulations to Jacx, self-inking rubber stamp. Too simple, but it does not get more correct than that. We'll get in touch with you, get you a Hackaday podcast t-shirt, and everybody else out there, thanks for playing along, and be sure to listen in next week.
Hey, I finally got a non-Star Trek one right. What do I get?
Applause! Yay! Well, my first hack this week is about multicolor printing, and we've actually got a twofer. The first one is from video channel Teaching Tech, and this is reducing poop on multicolor prints. And if you haven't done multicolor prints, basically the problem here is that when you switch filament, there's some of the old filament color left in it, and so you have to kind of extrude that out before you get a clean version of the new color. And that stuff makes kind of little, I don't know what, little squirrely things. They're called turds or poop in the business. I'm really sorry to you sensitive people out there, but it's just clearing the nozzle out. And so the question was, in this video, is there anything you can do to the actual slicing code itself to reduce the amount of extra wasted plastic that comes out of it? The answer that he came up with, and this is the one that's really effective and kind of the one we all know, is that if you're printing multiples of the same thing, you can print all the orange in one go and then switch out the colors and then print all the black in one go, and etc. So if you're doing multiples of the same thing on a per print basis, it can actually be pretty efficient. But if you're just doing one multicolor print, that doesn't buy you anything. People have come up with all sorts of crazy cockamamie schemes, like trying to bury the purge inside the infill layers. So, inside the print where nobody sees But that doesn't really work unless you have a lot of infill. And then you're wasting so much plastic on the extra infill that it's not clear that that makes any sense. And it takes a lot longer to boot. The one thing that he tested that I'd never seen before was switching colors strategically from lighter to darker and not purging as much when you do that. So like, the black kind of overwrites the yellow, but naturally it won't work vice versa. You can't switch from black to yellow without purging, but you can do a yellow to black transition. And that was a kind of cute idea, but even that didn't help as much as the effect of just doing multiples and kind of amortizing the cost of switching colors across a whole bunch of prints.
So when I saw the word poop twice in the Hackaday in a week, I thought, well, we must be doing something. We must have had a duplicate or something, but apparently no. It's interesting. I've done the multicolored 3D printing. I actually have what do they call it, a switching head. So, you push a little filament in, you print with it, you pull it out, you push the other one in. It doesn't mix or anything, and it all comes out of one single nozzle. But there are a few interesting things you can do, and I think it's Bamboo Slicer, if I'm not mistaken, has the purge to object, right? Where you can actually say, well, instead of printing a purge tower, I just want to print some object, and I don't care what color it is. So whatever color you got, use that, and it does that. But it does seem like it's a big waste problem. And of course, the more colors you have and the more switches you have, the more that's going to be a problem. So it's kind of interesting to see how everybody's working on that. And then you have to wonder, too, if that could bring a resurgence of multi-head printers, because if you don't really have the single nozzle, I think you have less problem with this, right? Because you just retract, cool down a little bit, and then go back later. So I think it's really the mixing and the switching heads that are really the major culprits here, right?
Yeah, absolutely. The other 3D printing poop post we had this week came from Stefan of CNC Kitchen, and this was his attempt to just recycle the stuff that comes out instead. So whereas Teaching Tech was trying to minimize the amount of waste, Stefan was saying, well, let's just melt it all together and make some filament out of it. And to that end, he actually made a filament extruder and took all the little spirals of waste plastic. He actually threw it in a heated vacuum chamber so that he could degas them, and that ended up being the real trick for him, and then ran them through an extruder. He ended up with kind of a gray, green, dull color because, it was this mix of everything he had lying around, right? It was all the different colored samples. But he actually ended up with something that was fairly usable, and this is really impressive. People have been attempting to do re-extrusion of filament a number of times, and it's definitely a hard problem by any means. There have been a bunch of great solutions, and Stefan leverages like kind of all the work people have done over the last 5-7 years on this. But the real secret sauce with his approach was to get the filament dry again. And he did that by basically vacuum drying it, throwing it in a heated chamber under a vacuum and getting the plastic mostly pure again. I have to say that's one of the best looking spools of self-extruded filament I've seen in a long time. Color aside, or maybe you like that kind of dark gray color anyway. So, kudos to him.
When I saw that, I was really thinking about an article we did last year where they were 3D printing multicolored filament and actually 3D printing the filament. And I'll put a link to that in the show notes. And I was wondering if that might be an option. It kind of printed a coil. So maybe the purge tower becomes this coil of multicolored filament around the edge of the build plate. You'd probably have to figure out how to move the head so as not to run into everything. But that might be possible also. I don't know. I haven't really given it a lot of thought.
I guess this is the problem with multicolor printing where you're switching out the filament, and it's really great to see people working on it, both on the side that Teaching Tech was working on, kind of the input side, reducing the amount of waste plastic, and the output side where Stefan was doing it in seeing what you can do with it. Both of these approaches are, of course, complementary to each other, and I love that one you were suggesting with just printing a sacrificial object that you don't care if it's stripy too. I'm sure there's many more creative ideas left in this field. If you see anything cool, let us know what it is.
Well, my first hack this week was from Jeff Geerling. and he's talking about how to reduce the Pi 5's power consumption. And I'll be honest with you, it's not really a amazing hack. What happens is for technical reasons, Raspberry Pi decided not to shut down the SoC when you go into basically an off mode on the Pi. And the reason is if you have 5 volts and not 3.3 volts, there's some add-ons that become upset about that. So as a result, even when you think you're drawing very little power, the system on chip is still running. But it's a very simple configuration change to make it go to sleep like everything else does. And as long as you don't have something that's affected by that problem with the split voltages, then you suddenly get this huge reduction in power. Now, I mean, first of all, it's great to know if you got a Raspberry Pi 5, but it also struck me that what power of the internet we see, if this had been 30 years ago and there was some piece of folklore about this computer, it would have been very difficult and it would have been passed, word of mouth. Maybe a magazine would have covered something about it after a 3 or 4 month lag. But with the internet, it's somebody figures it out and in a week everybody knows about it. So I think that's pretty awesome. And if you've got a Raspberry Pi 5, it's probably worth knowing about.
Yeah, totally. I actually was testing out the Raspberry Pi 5 and I didn't notice this, but I haven't been doing power consumption tests yet either. So, who knows? And I certainly haven't used it with any hats on it. So hasn't bitten me this problem. But still, like you say, it's a simple fix. It's a config fix. Boom. How can you go wrong with that?
You do have to wonder what add-ons are not working right if the voltages are half on, half off. And I haven't heard which ones that's affecting, but it just seemed like an odd problem to have.
Next up from me, Homebrew TEM Cell lets you EMC test your own devices. And this is a great piece of home test kit by Petteri Aimonen. And if you don't know what a TEM cell is, like I didn't, it's basically it's a metal box that kind of encloses your project and picks up any emissions that it might be spitting off. And so if you have a device that needs to get certified, you take it in, they listen to see how noisy it is, and if it's too noisy, it doesn't pass, and if it's not too noisy, maybe it does, and you win the lottery. But how do you know before you get in there? And that's the idea here, is that he wants to make his own kind of pre-official EMC testing rig to help make sure that he's got the device in question quiet enough. And so it's actually a really simple device. All the devil is in the details. I love he describes it as basically, quote, an expanded coaxial cable that's wide enough to put your device in. The one he makes is really beautiful. It's got kind of 2 triangles that expand out from a BNC connector and are both connected to flat copper planes above and below the device under test. You put it on a shelf in the middle, and whatever EMC it gives off, affects the ground and the active parts of the signal, and then you can read it out afterwards. The real trick here is in getting the impedance matching right, and he does that by changing the geometry of the triangle and the flat planes and all of that. And he gets that right so that it's tuned to 50 ohms like, your measuring device probably expects, et cetera, et cetera, et cetera. It's just a beautiful piece of simple building, and at the end, it's a really simple device. It's just a couple pieces of PCB material and a BNC connector, but getting it so that it's right and so that it measures just what you want is where all the science is here. And he does that for you. And if you wanted to see how you do it yourself in maybe, different frequency spectrum or different parts to use, whatever, you should absolutely walk through his not 1 but 2 blog posts on this TEM cell, because they're both really great. And even if you aren't going to make one, you might be interested in reading up on spurious electromagnetic radiation.
Yeah, the EMC testing, that's always been something of a dark art. I remember back in I guess it was the 1980s when we first started having to do that kind of testing. I thought, well, how hard can that be? And we decided we were going to do our own tests. And after about a week, we decided to pay somebody to do the tests. I mean, it's really not for the faint of heart.
It's the modern test equipment that turns all of this like radio stuff into no longer a dark art. Like, I mean, part of the reason it's been dark is because you haven't had the gear to see it, right? But if you have something, in this example, he's using a tiny SA spectrum analyzer, and a spec an used to be something super expensive and difficult, and he's got one that's, you know, under $200, certainly under $300. And so that plus a few pieces of PCB material and some, you know, careful measuring and cutting gets him a piece of measuring equipment that, you know, before used to be tens of thousands of dollars and now is totally doable on the home hacker budget. I think a lot of the dark arts are actually kind of having flashlights shown in their ugly little corners. You can see a lot more now than you used to be able to see in the past, and I think that alone is extremely useful and will help us push all of our projects forward.
Okay, my next hack is from Khan. Smart Ring measures blood pressure. And I just think that's another interesting case of where this is a relatively high performance measurement that would have been something a large team would have had to work on years ago. And now it's a 3D printed ring and a little bit of hardware. You know, the signals in your body are very, very weak. And so if you look, they actually inject a 10 kilohertz sinusoid into your finger and then measure the voltage drop with a Kelvin, you know, 4-probe Kelvin arrangement. And they were able to get very accurate blood pressure readings from that. I would hate to have to try to get that through the medical certifications if you actually wanted to use it in a commercial context. But for, you know, homebrew hackers, it's pretty good. I will say, if you looked at the main picture on that post, it took me a minute to realize that when it said digital artery, they meant the artery in your digit, not a digital artery as opposed to an analog artery. So I'm embarrassed to admit that.
Doctors have their own funny words for our parts of the body. Yeah, this is a great piece. It's written up by Orlando Hoylett, who actually is a PhD in biomedical engineering. So he actually does this for his day job now and writes for Hackaday for fun. So thanks, Orlando, for picking this one up. It's totally, totally cool. Actually, one of the really neat hacks that we saw at Supercon was by GC, who bought a cheap heart probe meter IC chip. It's one of those, you know, super sensitive amplifier chip. And it hooked up pads to themselves and were just graphing the heart rate out on the little vector scope meter using the raw voltages. I thought that was absolutely fantastic. And again, this was a little breakout board that you can make, and you can get these like hyper accurate instrumentation amps. You just put it on there and you're done, you know, a few bucks, and you could be reading your own heart rate and graphing it out on a hacker conference badge. So that's pretty awesome too. And, you know, a lot of this is being made possible by availability and kind of mass manufacturing of these super accurate instrumentation amp / ADC combo chips that are basically aimed at making heart rate meters, but in industrial applications. And so, again, when our folks get a hand on them, we can bend them to our will.
Well, this really reminded me of the way we used to do electromagnetic flow monitoring. And it was the same kind of thing where you had this extremely noisy, tiny signal riding on a big, giant, noisy signal. And there were a lot of special techniques like this that you used to read it back out. So I found it sort of nostalgic in that sense. But again, how cool that all this is happening in the hacker community now and not in the laboratory.
And bringing up the rear, I got most AI content is trash, just like everything else. And this is a write-up of an opinion piece by Max Wolf, who's been doing AI research for quite a while now. And he starts off by citing Sturgeon's law, which is basically 90% of everything is crud, and points out that the real problem here is that with AI, it can just produce so much more volume of everything, crud or otherwise, that the 90% is kind of risking overwhelming the good out there being done. And that he, as an AI practitioner, is kind of bummed about getting the continual backlash that he gets because, you know, 90% of it is crud, in fact. And actually, it's not simply his concern. That's going around the industry as well. I don't know if you folks out there have been following, but Adobe has put out an initiative to label AI stuff differently from human stuff so that they don't end up feeding the 90% AI crud back into their AIs. The problem is that you train these things on whatever data you've got out there, and it's kind of majority wins, right? They're statistical machines. They get pushed around by the average, and they are actually afraid that there will be so much bad stuff, just boring stuff or stupid stuff or incorrect stuff made by AIs out there that it's eventually going to poison their next round of AIs that are trained on the public internet data sets. And it's fun to see industry into that, and it's fun to hear Max's take here as well.
My last hack of the day, Ben Eady had the pocketable Yagi antenna, really shoots for distance. And he's actually built a 2-meter Yagi from copper foil tape that I guess you can just kind of fold up and put in your pocket. So if you're going out and you're trying to get gain and directionality in an antenna, that's a pretty compact package. I think we don't use copper foil enough. Years ago, I had the habit of actually taking stained glass foil. They use copper foil and staining glass and putting it on top of shoe boxes and making like little ersatz printed circuit boards with that. Any place you had the tape cross each other, you would solder it together. And if you don't have ICs, that works really well for like little RF. I did like a regenerative receiver and a transmitter. So this was kind of reminiscent of that.
My first quick hack this week is this OSHW trackball is ready to be customized, and this is the newest addition to, as Tom puts it, the somewhat unfortunately named Ploopy family. This is a sweet trackball in the style of those old Kensington trackballs. It uses a cue ball for the trackball, and it's got a sweet vision sensor underneath. Whole design is open source, and or you can buy all the parts you want from Madromi and make it yourself. If you haven't seen the Ploopy line before, it's a whole bunch of kind of reimagined 3D printable consumer devices, including a keyboard, a headset, and now a sweet looking trackball. Definitely check them out. It's some brilliant industrial design and of course all completely open source. Next up, Christopher Walker. Need a low mass antenna in space? Just blow it up. This is a really cute idea for lightweight antenna applications. It takes basically a balloon, metallizes the back half of it, and uses it as an antenna dish. Sweet, lightweight, maybe not white, optically / radio perfect, but it's definitely better than nothing in a pinch. And how much does it weigh? Not much. Brian Lowe has a new project. Cheap Yellow Display builds community through hardware. This is an ESP32 and a resistive touchscreen that you can buy for like $15. The problem is nobody's hacking on it, and his project here is to try to round up some enthusiasm to work on this device because it makes a super simple Wi-Fi connected screen with touch capabilities. You don't have to work hard on the hardware. It's all done for you for the low price of like $15. So if you're interested in hacking on the Cheap Yellow Display, go check out his GitHub. And last up, Brian Lunduk with The Many Ways to Play Colossal Cave Adventure after nearly half a century. Apparently there was a modern take on Cave Game, and then he's going through a lot of the old versions as well. If you haven't played Colossal Cave Adventure, it's like one of the oldest / most influential early text adventure games. It's the one that gave rise to Zork. You should check it out.
My quick hacks of the week. First off, Fuzzball Cat. Tiny fourth could be the smallest. This is a little tiny fourth interpreter in just a couple of 100 bytes of x86 code. I'll be honest with you. People say, oh, you could use it and it'll fit in a boot sector, what have you. The truth of it is it's just code golf, and I'm perfectly okay with that. But fourth is a particularly useful language for that since you can extend it easily. And of course, one of the original of these little tiny languages was Sector Fourth, which is a little larger, and Sector Lisp, which is also a little larger than this Milli Fourth that Fuzzball Cat has. Second up, Dr. Scott M. Baker, who always has interesting microcontroller projects, has an Intel 8008 on a single board computer. The 8008 is a vastly underrepresented chip. You know, the 8080 gets all the glory. But the 8008, you know, there was an article in Radio Electronics about building the Mark 8 and several other things like that. So it was certainly a hobby level computer even before the 8080. And it was nice to see Dr. Baker working with it and doing something kind of more modern than you would have had at the time, but nice. And finally, Our Own Devices, which is an excellent YouTube channel, by the way, had a gorgeous video of one of those machine instructographs that took paper tape and plays Morse code, and that's used for schools and training and what have you.
And that brings us to our can't miss hacks. These are long form pieces written by our fantastic Hackaday writing staff. And this week I wanted to pick Maya Pasha's article on Ethernet cable, all about cats and what Ethernet classifications mean beyond bigger number better. So you might have heard about the different categories of Ethernet cable, like Cat 5, Cat 6, Cat 7. Apparently there's a Cat 8 now. Who knew? The different categories, I learned by reading this article, refer to different spectral bandwidth to which the cables are specified. It's kind of a little bit tricky because what you might want to know is how many gigabits per second can I push through this cable, and that's going to depend on two things. It's going to depend on, one, the bandwidth of the cable itself, how much signal you can push down it, and two, the different encoding schemes, so how the data is making use of this bandwidth. Because the two of them interact, there's no simple answer to the question, I want to push 10 gigs, what kind of cable do I need? And she gets into that and demystifies a lot of that here. Along the way, I learned about one of the really neat modern data encoding systems, MLT3. It uses not just like high-low, but high, middle, and low signals. So it's plus 1 volt, 0 volts, minus 1 volt. And it uses transitions between these to signify a 1 or a 0. So a period with a transition is a 1, a period without a transition is a 0. But the direction that you're shifting up or down doesn't actually matter. And so what you end up with is this funny stepped wave that goes up and down, but it goes up and down much less quickly, like at half the speed of how often it would go up and down if it only had two levels, right? Because it can go from the high to the middle to the bottom to the middle to the high again, right, in one cycle. And so that's kind of a lower frequency than if it were just regular old encoding where it's like high, low, high, low, high, low to indicate the same series of ones. So it's a really neat modulation. You should check that out if you're a radio nerd. And then the rest of the details are surprisingly boring. It's like, is it wrapped in foil? Does it have a lot of copper in it? Et cetera, et cetera. And that, of course, makes manufacturing these cables hard and expensive, and it gets to the point that the higher categories now, the really high bandwidth cables, Cat 7, Cat 8, I guess Cat 7A and Cat 8, are almost as expensive as fiber. And one of the questions that came out of this article is this going to be the end of copper? When making the copper cables so that they have enough bandwidth becomes so expensive that it's as expensive as running fiber, is this going to be the end of copper? And you really should dig through the comments because there are a lot of knowledgeable networking people who weigh in on this and other topics, such as how much of the different categories is snake oil, etc. What do you really need to push 10 gigs? This is a super informative piece. If you're going to be pulling some cable soon, you should look at it, follow all of the links, and definitely read through the comments.
So I couldn't help but think about a podcast from a couple of weeks or maybe a couple of months ago where Dan was talking about how he met the guy that knows everything there is to know about tape. And there's guys like that for cat cable as well, right? There's all these weird parameters that you don't normally deal with, like next and fext for the crosstalk and probably a dozen others I don't remember. But yeah, this article did a great job of kind of giving you a quick introduction to what all's going in there, but that's a deep rabbit hole if you actually want to get into it. And there's, $1 million pieces of test gear for making all these measurements and everything. And it's just fascinating. So it's one of those things, if you really want to go down the rabbit hole, this is certainly a rabbit hole to go down.
And the $1 million test gear is kind of exactly the problem, and that's where she ends up this article. Basically, that is, you need to buy the category you need, but you also need to buy it from a reputable manufacturer, because like any sucker can just print Cat 7, Cat 8 on the side of their cable. Whether it actually makes those specifications or not, you're not going to know unless you have the super expensive test gear. So whether you're getting what you paid for, yeesh, you can't necessarily verify it until you've installed it. So buy good stuff if you're going to pay for this high-end cable. I don't know. I wish there were a way to test it. Actually, I guess there is. You can, once you've installed it, you can test the throughput. And Electrobob comes in and brings up Open Speed Test, which is free software that you can install on your own server and client and test the speed in between the two to figure out if you're getting as much speed as you think you are. Now, of course, again, that's all confused in with the different encodings, et cetera, et cetera. But at least if the question is, am I getting as much data through here as I want to, you can answer that question.
My can't miss this week was from Lewin Day. Fancy gyroscopes are key to radio-free navigation. You know, that's a topic that I'm always kind of interested in. Nowadays, if you say, we've got to build something that knows where it is, the obvious answer is, well, we'll put a GPS receiver on it. But that's a relatively modern thing, and it's also not always possible if you're underground or indoors. So there's all this very old technology for trying to figure out, well, I started from here, and I got to get to there. How am I doing? Where am I at? Some of that is celestial navigation, which is not the topic of this article. But a lot of it is just dead reckoning with a gyroscope where you measure the force essentially and say, well, if there's this force on the gyroscope, that means I must be moving in this direction with this much acceleration. And what's interesting is he really drills down into some very specialized gyroscopes like the ring laser gyroscope, which has the lovely Sagnac effect. I don't know why that always amuses me, the Sagnac. It just sounds made up, right? Oh, that's the Sagnac effect, but it's the real thing. And that's that thing where light repolarizes due to the change in the travel length, and it's very mysterious, right? It's one of those things that makes you think there's, maybe we are in a simulation. But there's also fiber laser gyroscopes that also use the Sagnac effect. And then there's the hemispherical resonator gyroscopes, which have a quartz hemisphere. Very expensive devices. We think of gyroscopes now as being a MEMS gyroscope that costs 72 cents in quantities. But these are not cheap gyroscopes. Their precision, though, is just tremendous. And when you're trying to navigate a ship or an airplane or a rocket, you need that precision. And so it's kind of a look into something that, again, a real specialty topic. If you don't do this sort of thing, none of this means much to you. But what a great look into some pretty exotic hardware that people use in space, on the ground, in the air, and probably some other places I don't know about.
I have to say, I absolutely love the look of ring laser gyroscopes. I was looking for more pictures of this when I was editing this article. Even just images of these things are unfortunately scarce on the ground. I had to dig one up from a textbook. I mean, it's crazy, but it splits a laser beam in two. Looks like something totally out of science fiction, but what it's doing is it's using the difference in path length between the one way and the other way. Whether it's rotating in the direction of one of the beams or the other, lengthens or shortens that path, and that ends up with different phases at the two ends of it. And that's that Sagnac effect that you were talking about. Is it Sagnac? Is he French? I don't know. Yeah, I wish I could use one of these fancy gyros. I don't have the bills or the need, but boy, do they look cool. That wraps it up for this week's Hackaday podcast. Thanks very much for listening. If you want to follow along with the links, head on over to hackaday.com/podcast. And if you see anything cool or do anything cool, drop us a line, tips@hackaday.com. And until next week,
keep those hacks coming.
Keep on hacking. All right. It sounds like you're in some level of hell with all the
Dante's
noise and
LAX.
stuff going on.
And I think Nardi's going to join us here shortly if you think we can survive it.
Oh, that's the worst thing that could happen, but,
I meant survive it technically, but yes. I've been trying to not scream into the microphone.
The true editing magic. See, he's so good off the. I'm going to say the normal one.